All right, everybody, let's take a look at this problem. We need to complete the mechanism of this reaction after we complete the reaction. So that first part is that we need to know what the products of this reaction are. So what do I want to look at? I want to look at this idea that I have, and I'm going to draw just a representative version. We've got a secondary amine and a carbonyl group, and those things are going to get together and form an ene amine. Remember, we would form an imine where the double bond would be between the nitrogen and the oxygen as long as there are two hydrogens on the amine or more. So right now there's only one hydrogen on the amine, it's secondary. So we can't actually form the imine, we have to form the enamine. And so let's take a look at that reaction in depth now that we know what the product is. The product is going to be an enamine. So let's look at the different structures that I have. I have something was a carbonyl group, and it had a quaternary carbon on the right side or the left side, and it had a methyl group on the right, which means that I can't form a double bond in the position on the left. And the reason I can't form a double bond there in the position on the left is that that carbon already has 4 bonds, so it can't make a double bond. So that means there's only one option for the double bond, and that's there. So let's go ahead and put the other R groups on that amine. And once we identify where those R groups are, we can go back to our structure and we can realize that those R groups are here. It just so happens to be that the R groups in this case are cyclic. So we want to make a 5-membered cyclic enamine. Now that we've completed the reaction, our job is to write the mechanism. And so remember, it's going to be 7 steps, and we always have to consider that the mechanism of the reaction should be consistent with the conditions of the reaction. And we notice that the conditions are acidic. So I've got some H plus in the solution, and one of the things that I'll think about is that I want to start off with not a proton transfer like we have been doing in this chapter, but this one is going to be a nucleophilic attack first. So in these nitrogen mechanisms, I start off with a nucleophilic attack of the lone pairs on the nitrogen to the carbonyl carbon, and I'm going to form a tetrahedral intermediate in the very next step. And remember that this thing is going to be a Zwitter ion. And because it's a Zwitter ion, the overall molecule is actually neutral. So there's the positive charge on the nitrogen. There's a negative charge on the oxygen, but the positive and the negative charge cancel out, leaving me with an overall neutral substance. Now, this is where we really need to think about the conditions of the reaction. Now, remember, the acidic compound in the solution is going to be the nitrogen compound. So I can draw it out, and I think I'll draw it out this one time, but in the future, I'm just gonna draw it in a more representative fashion. Now, there's some options here. Now, I could think about this next proton transfer, and I could say, well, I could take off that hydrogen, but remember, we need to have everything consistent with the conditions of the reaction. If we took off this hydrogen, then we'd be left with only a negative oxygen, and that species would be a strongly basic species, and that's not consistent with acidic conditions. So it's not this hydrogen that I want to do a proton transfer with, it's actually the oxygen. I want to go ahead and protonate the oxygen, and that will make the compound overall positive charged, and that is consistent with the conditions of the reaction, which are in general acidic, which means positive charge. So I'm going to have an OH group there, 2 methyl groups there, nitrogen, come along, finish that ring, still got a fourth bond, so it's positively charged. And there we go. Now we've got our next intermediate. So I just went ahead and finished or pulled off this proton on this nitrogen. So it's back to being neutral. And since it's back to being neutral, it's ready to go ahead and do another proton transfer. Now I could think about adding a proton over here, but then I'd end up with a situation that has two positive charges. And remember, two positive charges aren't likely to form in anything. So in that case, what I want to do is I want to do a proton transfer to the nitrogen to return it to a neutral state and reforming the catalytic acid. So that'll get me. Still got this OH group hanging out over here. And now I've got a neutral nitrogen attached where that carbonyl carbon used to be. Okay, now I can go ahead and here I'm going to switch to representative now. R2 H plus. Again, remember that this species is this species, and I'm just replacing the two R groups with that ring. So now that I've got this acid, I can go ahead and protonate this oxygen. Remember that the oxygen ultimately has to be a good leaving group. That's where we're going to turn it into water, because you see that in the final product, we're not going to have that oxygen group there, so it has to leave. And in order for it to leave, it has to be a happy little leaving group, and water is a really happy leaving group. Okay, so now that the water is ready to leave, we can use the lone pair on the nitrogen to form a double bond there and kick off the water. And so what that does is that it makes something that looks a lot like an imine. You now have a double bonded nitrogen. Here's our two R groups that are shaped like a ring. But in this case, it's not neutral. It is positively charged. And we notice that our final product is neutral. So we have to do something to make it neutral. And that's where this hydrogen comes in on this carbon at the end. So I'm going to have that now neutral amine group come along and do a proton transfer. That's going to form this double bond there, move the lone pairs in this bond back up to the nitrogen, and ultimately that's how we form our product. So you had to be able to complete the reaction, which means you had to know that the product of the reaction was an enamine. And once you knew that the nucleophilic attack was the first thing that happens in the reaction, then everything else really was just a consideration of what the conditions of the reaction are and how do we get rid of that oxygen group in order to form the final product, which of course is absent of an oxygen group. All right, thanks guys.